again what we've been doing here. So we're going to just kind of put the last problem we did on hold because I really do find it hard for students to understand when we like stop a problem in the middle and then to go back to it. Sometimes that overnight of like, wait, what were we doing again? So we're going to just start with a fresh problem here. Our learning target, our goal is we're still graphing rational functions. Just to remind you, what we started off with yesterday was we didn't have a vertical asymptote. There was an imaginary solution there when we set the denominator equal to 0. So as a result, there was no vertical asymptote. We did have a horizontal asymptote, and all of the function was below it, okay? The next thing we noticed is we needed to scale. So before we started plotting any points, we started plugging things in and we looked at what our y values were. And our y values were all under 1. So we said instead of making each tick mark worth 1, let's go by 0.1s or 0.2s. Today you're going to have to do that. You're going to have to scale. In fact, you might have a y value at 25. So if you had a y value at 25, what would it make sense to scale your y-axis by? 5s, exactly. Very good. So that's just a problem-solving piece that you need to look at, an analysis piece there. Let's start from the beginning there. Number 1, though, we need to find the vertical asymptote. Hopefully you have this memorized by now. How do I find my vertical asymptote? Make the denominator equal to 0 and solve for x. So my vertical asymptote, x squared minus 1 is equal to 0. There are times when you may have to factor this to solve. Okay, going back to factoring. There are times when you may need to use the quadratic formula to solve. Or you could use square roots to solve. What would be your preferred method here? Algebra. Okay, add 1 to the other side. We get x squared is equal to 1. And what is x equal to? Plus or minus 1. So what do you notice, guys? We have how many asymptotes? 2 vertical asymptotes at 1 and at negative 1. Next, we have our x-intercepts. This one, it would be okay just to set the numerator equal to 0. We don't need to do the whole cross multiplication. You can. When is it that you do need to use that cross multiplication? Do you remember? Yeah, exactly. When there's a constant out here, you have to bring it over to the other side, put it over 1, and do cross multiplication to find that x-intercept. So here we really could just set 3x squared equal to 0 and solve. And what is x going to equal? Yeah, your x-intercept is going to be 0. There are times when you won't have an x-intercept. There are times when you won't have a y-intercept. For our y-intercepts, how do we find that y-intercept? Yeah, make x 0. Very good, very good. So I plug in 0 here, right, and here. And what do I get? 0, yeah. My horizontal asymptote. Here's where I need to analyze the degrees of the numerator compared to the degrees of the denominator. And what do you notice about the degree of the numerator compared to the degree of the denominator? They're the same. And when they're the same, what do we do? You divide it's the ratio of the leading coefficient of your line leaders there. Okay, so that's going to be, oops. Y is equal to what? Y is equal to 3. Very good. Because my leading coefficient here is 1. So I take the ratio of that 3 over 1, which is 3. Okay, next. Now we don't know if we need to scale yet. So let's go ahead and make that table. We do know that I'm going to have a vertical asymptote at 1 and -1, so that can help you with how you're going to plug things in. So I'm going to ask for your help again with figuring out what these values can be. I'm going to go this way this time. So I know I have a vertical asymptote at -1, so I'm going to pick -3 and -2. What would happen if I picked -1? Yeah, there'll be no solution. I'm also going to pick -1/2. Okay, I'm going to pick 0. Well, I already know what 0 is, right? I'm going to pick 0.5. And then I'm going to pick 2 and 3. Why did I pick the -0.5 and 0.5? Yeah, they're in between. So you can see here, these numbers are to the left of the vertical asymptote. These numbers are in between, and these numbers are to the right of the vertical asymptotes. So right now what I'd like to do is I'd like Vincent's row, you guys take -3. Emma's row, you guys take -2. Alec, you guys take -0.5. Sierra's row, you guys take 0.5. You guys take, Sarah's row takes 2, and you guys' row takes 3. And you're plugging your X value into the function, and you're seeing what you're going to get. So please do that now, and just watch out how you're plugging things in your calculator. I'll do it with you so we can all kind of double check each other. All right, when X is -3, I got 3.375. Did you guys get that? Okay, 3.375. When X is -2, what'd you guys get? Yeah, I got 4 as well. -0.5, what did you guys get? How about 0.5, what'd you guys get? -1? Did you get -1, Yanni? -0.5? Okay. For 2, what did you guys get? I got 4. Did you? Okay. And then 3, did you get 3.75? All right, ladies and gentlemen, we see our Y values now. What would it make sense to scale by? Can we go by ones? Is that okay? I think so. And our X values, is it okay to go by ones? Yeah, I think so too. Okay, so let's do that now. Let's scale it out. 1, 2, 3, 4. 1, 2, 3, 4. Let's go 1, 2, 3, 4. 1, 2, 3, 4. Okay, we'll start with our vertical asymptote. In blue, we have one at 1 and -1. Questions there? Okay. Next, we have an X-intercept at 0. So I'll do that in red. And a Y-intercept at 0. So we're at the origin there, 0, 0. We have a horizontal asymptote at Y is equal to 3. And then we have our points. Okay, so at -3, 1, 2, 3, I'm at 3.375. So I'm about right here. At -2, I'm at 4, so I'm up 1. Okay, at 2, I'm at 4. At 3, I'm at 3.75. So what is this graph going to look like? Well, it's going to be a curve, and unfortunately, I wonder if I can go like this. Give me a second. This is kind of nice that we can do this. Why am I doing this right now? Yeah, I can go up higher now. And now I know my graph, we know that it kind of hovers around those asymptotes. So now negative 0.5, I didn't bring the table. What's happening in the middle? Negative 0.5 was it negative 1? You guys? Okay, and then right here? Okay, so we don't know for sure, but we can predict that this might be our highest point. It might go up a little bit here, but right now but we know for sure that it goes back down, right? Reading left to right, we know we go down, up, back down, okay? So, and we know it hovers around the asymptotes. And what am I going to want to do? I'm going to want to go on Desmos to confirm. Okay, I want to go on Desmos to confirm. So this example from yesterday, how does it differ? From yesterday, we had no vertical asymptotes. Today, we have 2 vertical asymptotes. Look that over. Do you have any questions? What I'd like you to do is I'd like you to draw a nice horizontal line right under this because we're going to venture into what's called the slant asymptote now. Okay, the slant asymptotes. And we are continuing to graph rational functions, day 4. And my question is, what if I have a function that looks like this? Y is equal to x squared minus 1 over x. What do you notice about this compared to our other ones that we've done? Yeah, the highest degree is on the top now. So we've had the case where the highest degree is on the bottom. We've had the case where they're equal, and now the highest degree is in the numerator. And in walks then the slant asymptote. Do you know, guys, know what Mr. Irwin calls it? He calls it the asymptote. Asymptote. All right, just remember, friendly reminder in recording. How do we figure out what the slant division is? The slant division, the slant asymptote. In walks long division. You will use long division again next year in pre-calculus when we're doing this, and again in calculus, okay? So let's cruise, huh? We're not going to do this actual one. We're going to get right to 2. I want to try to get through 2 examples, but we're going to start off all the same way again. So write down this problem. Everything's the same. Now step 4 though is just, it could be a horizontal asymptote or a slant asymptote. When are we going to use this in real life? Good, Grant, this is real life. We're using it in algebra too. Okay. Y is equal to x squared minus 2x minus 3 all over x squared minus 4. As you're seeing quadratics, I do want you to kind of be thinking, oh, is something factorable? Okay, because eventually when you guys get through pre-calc and calc, you'll have to factor these and you're going to look for something called wholes. We don't do that in algebra 2, okay? But be thinking, can I factor that numerator? Can I factor that denominator? So to challenge you, can you factor the numerator? Does anyone know the factors there? All right, think about it. We're going to get into that on Monday. Yeah? X minus 3x plus 1. Very good, very good. But the vertical asymptote, let's go into that. We'll get back into factoring again on Monday and Tuesday. So if you just need your mind to break still from factoring, that's okay. The vertical asymptote, we still set that denominator equal to 0. Do I need to show my work there? Can I do that in my head? Yeah, that one's a pretty easy one to do in my head. X is equal to 4. The x-intercepts. Oh, wait, I do have to factor today. Okay. The x-intercept. I don't have a constant, so I don't need to do that's on the end over here. I don't have any like plus a number to bring to the other side and use cross multiplication to figure out the x. So I can just set the numerator equal to 0. Well, I have a quadratic. I have to factor this. I need to think what times what gives me x squared. And you guys are good at factoring. All our tests where we've had to factor, you guys do really well. It's just been a little while. So it's like riding a bike. You might be a little wobbly at first, but you'll get back on. Okay? So what times what gives us x squared? That's x. Then we need to think what times what gives us -3, but the outside and the inside, when added together, these quotients have to give us -2. So -3 plus 1. So what is our x-intercept? Well, now what did we discover? We have 2 x-intercepts. So we have an x-intercept when this is equal to 0 and this is equal to 0. Don't you love how it's just all coming together as like one? What is x equal to? X is equal to what here? Yeah, x is equal to 3 and x is equal to -1. 2 x-intercepts. Oh, and I said what? I don't like it like this. I'll write a little int. Okay. Step 3, the y-intercepts. Do I need to show my work for step 3 for the y-intercepts? No, if I just plug 0 in here, I know it's 0, right? 0 here. What's my y-intercept? 3/4. Very good. My y-intercept is 3/4. Why is it 3/4? Well, x squared 0. -2 times 0 is 0. So the numerator is -3. The denominator 0 minus 4 is -4. So -3 over -4 is a positive 3/4. And then finally, that wonderful slant asymptote. How do I know that it's a slant asymptote? I know it's going to be a slant asymptote because the degree of the numerator is larger than the degree of the denominator. So now I need to use long division. So let's review long division. I have x minus 4 over here. The denominator will always go right there. I have x squared minus 2x minus 3. What happens, ladies and gentlemen, if I'm missing a term? What if it was just x squared minus 3 instead of x squared minus 2x minus 3? Add an ox, I always like to call it, a 0x. Okay, we need a placeholder there. That doesn't happen there. I just want to forewarn you because it could. And now we just need to think. X times what gives me x squared? X. I like to keep it organized by putting it in line. What do I do now with this x? Yep, distribute it to the x and the -4. So x times x is x squared. And x times -4, -4x. Once I multiply, what do? Yep, so I could flip the signs and combine, which is the same as adding, okay? So I'm going to now make this a negative and this a positive and combine. I'm trying to go a little slower here because it's been a while. I'm going to cross this off. And I have negative 2 plus 4, which gives me 2x. Now what do I do? Drop the 3 down. Very good. Minus 3. And now I start the process over again with x and 2x. So x times what gives us 2x? 2. Very good. Positive 2. I multiply. 2 times x is 2x. I multiply. 2 times negative 4 is negative 8. And then what do? Change the signs. Negative, positive. This cancels and I get 5. What is 5? That's our remainder. And what's really nice, yep. Very good. It would be plus 5 over x minus 4. But the nice thing about the slant asymptote is we don't need the remainder. So we just ignore the remainder. So what is our slant asymptote? Our slant asymptote is y is equal to x plus 2. Okay, so I'm going to go back to my other page because I didn't have room. So step 4, my slant asymptote is y is equal to x plus 2. And now I'm going to find my points again. And the reason I'm going to find my points is because I need to know how I need to scale it, because you will run into those issues. Okay, so let's do it again. I have 2 vertical asymptotes, and I'm going to pick a bunch of points. I'll probably pick more this time. Negative 1 is, oh, I'm sorry. No, I only have 1 at 4. Let's pick a bunch though, okay? So I know I have an x-intercept at negative 1. So I'm actually going to pick negative 2 and negative 3 as well. So I get a really good picture of what's going on. I'm going to pick 0. I'm going to pick 1. I'm going to pick 2. I'm not going to pick 3. I'm not going to pick 4, but I'm going to pick 5 and 6. So this is why these problems take such a long time, getting these points. Now, if any of you do own a graphing calculator, during work time, let me make sure to show you a really cool function on your graphing calculator. I'm not certain it's on the other ones, but I can show you how to get these points really quickly, okay? So, and I can even show you just now like how I can do it. So if your brothers or sisters have a graphing calculator at home and you can just borrow it while you're at home, you just plug your function into the Y1. So I'm going to go kind of quick. So if you have a graphing calculator, I want to quickly go through it with me. I put it into my Y1, which is my Y equals. Okay. Who has got a graphing calculator in here? Okay. So I'm putting it into my Y equals right now, and the numerator will have a parentheses. The x squared button is right here next to the comma. Okay. And then I'm going to divide it by x minus 4. And decimals may do this as well. I just don't know that they have it. And then what I'm going to do once I have it in my graphing calculator is I can hit second graph, and I have a table with a bunch of values. And that right away is my table of values. Those are my X and Y numbers. Okay, so if you have that, I'll show you during work time how to do it, and I'll play around with some of the others. How many of you in here have an Android? Just raise your hand if you have a Droid. The Droid has these on as an app. So you can get this exact graphing calculator as an app, which is really cool. Unfortunately, the iPhone does not have it. And I will show you how to get that one as well. Okay, so at negative 3, we are at negative 1.7. At negative 2, we're at negative 0.8. At 0, we are at what? What did we say 0 was? 3/4. At 1, we are at 1.3, repeating. At 2, we're at 1.5. At 5, we're at 12. At 6, we're at 10.5. Okay. Let's do a negative 5 as well, just to see where we're at. At negative 5, We're at negative 3.556. I know some of you guys are tired, but my voice can't be that boring. Let's quick finish this problem strong and we're almost done. Okay, I know these are a lot of work. I promise I won't give you that much homework over it. Okay, and I'm doing this so I can make it a little bit smaller. So give me a second. And again, those of you who have been gone, these are all on video, so I do expect you to watch the videos. Okay. There, that's nice and small for us. Okay, so I have my X and my Y. Overall, what do you guys think we should scale this by? Yeah, I think 0.5 would be a good one as well. Okay, we do have some that are up in like the 12 and the 10.5, but we can just estimate that as we go. So I'm going to go by 0.5. If you need help scaling, let me know, but it's always helpful just to look at the table. The x-axis too, again, I think we can go by ones. So we're going to do negative 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. We're going to go by 0.5, so this is going to be 1, 2, you know what, I might actually go by 0.25. Or no, let's do 0.5s, I lied. 1, 2, 3, 4. Negative 1. Are we okay here? Okay, I'm going by ones here, so I have 1, 2, 3, 4, 5, 6, negative 1, negative 2. Are we okay so far? Let's finish strong, guys. We're almost done. You guys are doing a wonderful job. So I have a vertical asymptote at x is equal to 4. I have an x-intercept at 3 and negative 1. I have a y-intercept at 3/4. At negative 2, I'm at negative 0.8. At negative 3, I'm at negative 1.7. At 0, I'm at 3/4. I already have that. At 1, I'm at 1.3 repeating, it looks like. At 2, I'm at 1.5. At 3, I'm at 0. At 5, I'm at 12. So I'm way up there. And at 6, I'm at 10.5. So I'm way up there, right? My slant asymptote is y is equal to x plus 2. This is back to like linear algebra, algebra 1. Y equals mx plus b. I'll do this in a different color. I'll do it in red. So my y-intercept is at 2, and my slope is at 1. So I'm going to go where? Rise over run. Run up 1. Now remember, we're going by 0.5, so I'm going to run up by 3 and go by 1, right? Up over, and then down. And here's my slant asymptote. Now I need to take another picture. Okay. How are we feeling so far? Whoops. Holy smoke, come on. There. Okay, so I know right now, guys, right? I know that this asymptote is going way up here, and I know that this one's going like this. We know what this one's going to look like, right? Would you agree? This bottom one is going to look something like this. Are we okay there? Okay, but we need to know what this top one looks like. Can anyone kind of predict what it's going to look like? Okay, so with the slant asymptote in red, how did we graph that? That's a y equals mx plus b. In here, it will always be a y equals mx plus b. So I go to my y-intercept at 2, and I rise up 1, over 1, up 1, over 1, and then back down. And again, those asymptotes are help guiding us what's going on here. Are we okay? Okay. Now, I don't have the table with me. Can someone tell me at the value of 5, what did we get? 5, we were at 12, so we're up here. And then at 6, we were at 10.5, so we went down. So what do you think this one's going to look like? Yeah, the opposite. Very good. It's just going to look like this. So again, it's going to hover around those asymptotes. Questions there? So the biggest thing is just this scale. If you need help with the scale, let me know. Your assignment is on Schoology, so I'll show it to you here. You have a worksheet that goes with it, but so if you've been gone at all, you can see day 1 was Monday, day 2, guys, was Tuesday, day 3 was Wednesday, and then your homework today are 2 assignments. It's a Slant Asymptote worksheet, and I'm going to tell you there's there's 6 problems, so let's do the evens, okay? Do you guys all hear this? The evens on this worksheet, and then you still need to do the book assignment here, page 569, and I shortened it from yesterday to 3 problems. So you have 6 problems total. Just know that this 569, this is, okay, listen carefully. 569 is off of the example from yesterday. The second example from yesterday, ignore because we didn't finish it. And then the first example from today. The slant asymptote is the one that we went through just this last one. Are you okay there? So tomorrow there's nothing new. We'll do an entrance/exit card and just kind of let all of this sink in because it's been 4 days now of something new each day. So any questions? Yep, so the slant, okay, so page 569, due Friday. And then the slant asymptote, and I'm going to change that right now to just do the evens. Okay, does that make sense? 50, yes, so it's 3 problems on one assignment and then 3 problems on the other. Say what? Yeah, we're doing 8, this is 8.3. Okay, hold on. All right, I'm going to stop recording.